Hi everyone, my name is Tovio Roberts, and this is our first Galvanize DSI Prep Study Hall. Basically, what we're going to be doing here is starting at the beginning of the Data Science Basic Prep materials on Learn, and going sort of end to end on them, and I'll be answering questions as we go. Feel free, if you are in our Slack channels, in our Slack network, feel free to post questions in a thread under my post where I announce that I'm streaming. In fact, if you're not in Basic Prep currently, you can, or our Premium Prep, either product. The Basic Prep is free. You can sign up for it if you have questions as we go, and I'll do my best to engage with you, but only via the Slack channel. It's a lot easier than jumping between the YouTube chat and the Slack channel. I've actually turned off comments, or turned off chat for this live stream. So if you want to sign up for Galvanize Data Science Basic Prep, the link is in the description. Actually, I think there's a little bit of superfluous information in that description as well. Let me just fix that so that there isn't any confusion around it. Yeah, just give me 1 second and I'll get to that. So I'm going to be working in sort of this split screen that you're seeing here, where I'm going to have the materials for our basic prep on the left, and I'm going to have a code editor. This is VS Code on the right, and I'm going to have a terminal which I'm going to use to run VS Code. So this is just how I'm setting it up. However you want to do this is fine. If you would prefer to use repl.it, which I'll just open up in another tab, replit, that's perfectly fine. In fact, if you're new to Python, replit might be a lot easier for you to work with at this point than going through the whole Anaconda installation and then installing VS Code and then figuring out how to use your terminal, navigating to the correct location and everything like that. I'll dig more into that in another study hall. I'll just talk for it a bit here. So here's replit. I'll put a link to this in the description as well, just so, oh yeah, there's a little bit of erroneous information. Let me just put in, feel free to utilize replit to run your code. And I'm hoping that by changing the description here, it will actually update it for you. You might need to refresh the stream to see that. Okay, so if you're in replit, you can just go to new REPL, and we'll wait for that to come up and click on Python, and that'll give you, I'll just demo this really quick. That'll give you a quick coding environment to use. This might be a little bit zoomed in. We'll find out. Okay. So if I were to use replit, I would probably just throw this over here. One drawback of using replit is it takes a little bit of time to load sometimes, and occasionally it'll lightly crash and you have to reload it or refresh the window, which isn't a big deal, but eventually you're going to want to move to a text editor, like a more pure text editor that isn't browser based, and use that. So I'll just run a quick hello world here, just print, and then hello world, and then what I can do, I guess I'll zoom out just a little bit. I can hit this play button, and that will show me in my terminal on the right. So you code on the left, terminal on the right in this environment. I think you can also pop out the terminal and do things like that, but I'm not going to do that. In fact, I am going to work solely in VS Code and a terminal down here. You can also use the terminal within VS Code if you're more familiar with that. I personally don't like that very much, so I'm not going to do that. I usually use a separate terminal because the VS Code terminal can be a little bit buggy, or in my experience, the terminal can be a little bit buggy. I'll just turn up my mic slightly. And yeah, that looks a little bit better. Let me make sure I'm not, let me make sure that that's not, okay, yeah, that looks fine. All right, okay, so yeah, let's just poke around in basic prep for a second. We've got this welcome section, and if you're in the premium prep class and you're watching here, I've already talked about this, but let's just scan through this welcome section. So welcome to data science prep. I'm going to look in this unit, welcome to data science. And this is just an overview of the blocks, the different sections that we have in data science basic prep. So essentially what this is saying is that that this is going to prepare you for the technical interview for the data science immersive. And that's generally what all of our prep materials are about. The other thing that this is going to do is give you kind of a general foundation in Python and a sort of intro stats in college level for the probability and statistics concepts that we require for you to know for the data science immersive, especially to pass the technical interview. So that's kind of what this is saying. There's a little bit in here about metacognition and practice and experimentation. You've probably heard me say this if you're in one of the classes or if you've been watching videos where I'm coding. It takes a lot of practice, and it takes a lot of experimentation. It takes looking at your code and thinking about it and thinking about the way you think. And no two coders are going to code the same, and that's completely fine. Also, you're going to build new ways of thinking about problems through learning code, and that's going to be fun. It's going to be interesting, if it's interesting to you, then you probably should be in coding. If it's not interesting to you, that's completely understandable. Maybe it's not for everybody, but I sort of think it is for everybody. There's a little bit of justification in this lesson on the importance of probability and statistics, and essentially for data science, there are a lot of probabilistic concepts, and data science is, in some sense, the evolution further from statistics. Some people call things that you do in data science statistical learning or machine learning, or there's just a number of terms floating around. I'm going to jump between terms if I'm talking more generally about this space. But for now, just know that probability and statistics are important. They're going to heavily inform the algorithms in machine learning if that is the direction you're going in. So in these study halls, I am going to focus almost solely on Python. I'm going to go through the intro Python and intermediate Python sections before I do any statistics. So if you're in the premium prep class, the current premium prep class, I'm teaching the statistics, applied statistics with Python. But I'm not going to cover much of that at all until we complete the intro and intermediate Python. So if you're watching these, it's not going to follow directly with the premium prep course if you're in the premium prep course. However, if you're in either the basic prep or premium prep course, please feel free to ask questions in the Slack thread, and I'll do my best to get to them in our allotted time. The other products, the paid products we have, that correspond to basic prep. That's just our premium prep and our mentored prep. Premium prep is what we suggest for most people if they need a more structured space. But we also say, if you are a good self-learner, don't worry about taking premium prep. We're still going to be available to you when you need us. You're still going to have access to a lot of enough resources. I'll say enough resources to get you ready for the technical interview. If you're not very good at structuring your own self-learning, then premium prep is a really good space for you. We create a lot of benchmarks, and we kind of pull you forward through it. You get a little bit more mentoring and things like that. I'm not going to talk about mentored prep here. That's basically for people who need structure and need somebody to check in with on a regular basis, but are unable to take the premium prep course for scheduling reasons or other reasons. And like I said, it's going to take a little bit for us to get to the coding today, at least, because we are going to use these study halls to go end-to-end on the materials. So in terms of the different sections of the course, we have this welcome section that we're looking at right now. We have Intro to Python, Intermediate Python, Intro to Statistics, setting up your environment. We have a section of practice problems that at this point, as of July 2020, is a little bit dysfunctional. I mean, there's a number of problems in there, and we're revamping it. We're going to add more problems, or we're going to create a different sort of practice section than what we have up there. In general, what we recommend to people is to go out to Code Wars and really work in Code Wars and do your practicing there. So to give you some idea about Code Wars, let me just pull that up really quick. Okay. There's going to be a little bit of lag for me in terms of my browser speed because my computer is a little bit on its way out. I actually have a new computer on the way, and specifically for streaming, that's going to be able to handle some of this overhead of using open broadcasting software and things like that. Some of the big resource hogs for streaming. So Code Wars, what this gets you is a space to practice a lot of different problems. And if you go over here to Kata and click on that in the side menu, you'll have to make an account, obviously. But if you go over to Kata, then you can start practicing on various problems. I actually have, if you look at the front page for our YouTube channel, I have a video on Code Wars that is in the Latent Topics in Data Science playlist, which is a weekly show I do on Thursdays. It's a kind of code along of generally of some statistical concept or Python concept that maybe a little bit tangential to our learning materials, but we have it there to spark interest and to teach things that we don't teach in basic prep that might be particularly interesting to you. Like the SIR epidemiological model. I do a code through of one of those. I do a graph network and write Dijkstra's algorithm, shortest path algorithm. So some of it's a little bit beyond the skill level of what we teach in prep, but it kind of sits in between. Well, some of it sits in the skill level of the actual data science immersive. Most of it sits just prior to the data science immersive. So if you're interested in some of those other topics, feel free. So here, Code Wars, if you select 8Q, that's going to be the easiest problems. 1Q are the hardest problems. And you'll want to select Python under My Languages and start coding. And like I said, if you look in that Latent Topics in Data Science playlist, you're going to see a video on Code Wars. So I'm going to close this out. And there's actually, sorry, that's my dryer in the background. There's actually one more section that we don't have listed here, and that's, we have one more section, and that is some extra topics in linear algebra, SQL, And I believe we have some information, some tutorial on pandas in there as well. But let's continue forward. I'm going to try to speed through this pretty quickly. It's probably boring to some of you, but just laying the groundwork. Okay. So this unit is really important if you're trying to pass our technical interview. The expectations unit. So I'm just going to skip to an actual lesson here, the actual lesson for what we expect for the technical interview. And I'm not going to talk at any length about this, but I'm going to point you at one very important resource in here when we get there. So we try to encourage people who are in the prep pipeline to interview early. We see prep as being something to get out of the way. Once you pass your technical interview, we can guide you. We can give you specific resources that will benefit you in day one of the DSI, right? What to study specifically for the DSI after you have the requisite skills. Those requisite skills being Python and statistics and applying Python to statistics. So we say interview early. Notice the interview deadline is 3 weeks before the DSI start date. That's really important. You know, we have to do the cutoff then, because otherwise people aren't going to have time to prepare for day one of the DSI. How do you know if you're ready? What I'm going to say here is it's sort of hard to know if and when you're ready. But the one really good way to find that out is by watching this playlist of videos. So this is a series of lectures I did last fall, I think mid or early last fall, and they're still relevant to our technical interview. Essentially, it's taking you through a specific analytic approach, and it's going to be using dictionaries to analyze functions. There's 10 videos in this playlist, and if you go through them, what you're going to see is very relevant to the technical interview. There's a workflow, there's a problem solving and analytic technique that you can learn here. And, you know, it's going to involve discrete distributions, and I cover the basics of those discrete distributions in these as well. So let's say you have done some Python and you've done some stats. You may not really need to go through all the prep materials. You should go and watch these videos, and let's say you get 3 videos in and you're like, oh, this is over my head. Then come back to the prep materials, right? That's 15 minutes of your time just to show you whether or not you are at a level of skill where you can understand what we're presenting or what we're going to ask you to do to pass the technical interview. Now, if you go end to end on these videos and you're like, I could code all of this from scratch, well, take the technical interview. Don't wait. You know, we don't want you to wait unless you're actually not ready. So you can check in with us and we can give you a self-assessment, you know, just a Jupyter notebook that you can go through, and if everything in there seems pretty easy, well, you're probably ready for the technical interview. Also, if you look through these videos and you're able to code everything from scratch, you're very likely ready for the technical interview. Okay, that's a lot of words. We talk a little bit here about the purpose. You know, this is something you can go back through and read about. I encourage you to if you're planning on taking the technical interview. So, is there anything here that's relevant? I mean, the whole thing is very relevant. We try to keep it as succinct as we can. Okay. So let's see what's next. I'm going to check Slack to see if there's any questions. And I'll probably do that occasionally. Okay. Python built-ins to know. We have a list of what we expect you to know. And we tell you what data types. So essentially, you should know how to use any of these data types or where they're relevant. You should know how to use all of these operators. Here's a set of functions. These are all built-in functions you should know, and built-in methods on each data type, we have it separated out by data type. And I believe we have one thing I'm going to also suggest is that you know how to import from random or from math certain functions, right? Like being able to import factorial from math, or E, being able to import the random function from, or the choice function from the random module, things like that. Okay, I do see a question here. Let's see. There's a question, what is that Jupyter notebook you mentioned before the interview? I will put a link to it. It's definitely not required. It's something that we send out when somebody, sometimes when somebody doesn't pass their first interview. It's just the kind of thing that if you can work end to end through that and it's pretty easy, that, you're probably ready for the interview. If it is particularly difficult, it might indicate to you that you need more practice. It is a self-assessment. Let me see if I can just find that really quick, and I'll put a link to that in the description. We're not trying to hide it by any means. When we're in interview crunch right before the cutoff for the DSI, we might not be able to meet with you if you've failed an interview, let's say, or if you haven't passed yet, and we like to say it that way. And in, oh, you know what, I believe I found it. Just lost my train of thought. Okay, so this notebook that I'm going to put in the description, if you're able to work end to end on it, you're probably in a good spot. We use it as a way to allow, have students assess themselves when we're close to the interview cutoff. Otherwise, if you don't pass your interview on your first attempt, we'll meet up with you. We'll reach out and say, hey, let's have a session and talk about what you can work on. That's essentially the purpose of this. It's kind of a stopgap when we don't have as much bandwidth, which happens pretty much near the cutoff date for every interview. That's another reason to interview early. We just won't necessarily have enough time to meet with you post-interview when we're close to the cutoff. So let me drop this in here. And I'm going to put this in the Slack, and I'll also put it into the description for this stream. So feel free to work through this notebook in prep for the TI. And go ahead and put that in there. And that answers, I think, the next question. May I get the link to the Jupyter Notebook to self-assess? And yes, I just put it in the Slack, and I'll put it in the description. Is there a calendar or some such we can import for this kind of thing? I'm not sure what that's in reference to, a calendar. Sorry if it was mentioned somewhere, but if it was, I missed it. Are you referring to the study hall? We don't have an explicit place where we mention the schedule for the study hall at this moment, but the tentative schedule is Monday and Wednesday from from 3 p.m. to 5 p.m. Pacific time. And it's going to be pretty much a walkthrough of the materials on Learn. I hope that's answering your question. If not, go ahead and follow up. There's another question. Should we have basic knowledge of pandas and NumPy before the DSI? Yes, but you don't need it for the technical interview. So once you pass the technical interview, we try to shift your studies toward linear algebra using NumPy if you have weaknesses there. We really heavily recommend getting as good at pandas as you can once you pass your technical interview. But I wouldn't recommend studying pandas before the technical interview unless you feel very solid in Python and you think you're going to breeze through the technical interview, and your interview is scheduled pretty immediately, and you just know that you're going to do great on it. So yes, the calendar question was for the study hall. I'll find a place on our Learn materials because this is a fairly new thing that we're doing, and we're going to do it at least through the duration of, well, I think we're going to do it at least until the October cohort starts for the data science immersive. So it does make sense. It's a little bit of an oversight on my part to not have put it into the basic prep somewhere. So I'll put it in there somewhere. Okay, let me just throw into the description for the stream. There it is. I'll just throw a link to this self-assessment for anybody who comes across the stream otherwise. I'm really excited to get this new machine because you know, I'm having some overheating problems on my oh wow, the description on this didn't stick. That's okay. Go ahead and change the description. Okay. So I'll just put a link to the self-assessment notebook. And hopefully this will synchronize right away. The other link that I just put in did not, so we'll see. It's not a big deal if it doesn't. There might be a little bit of erroneous description or extraneous description in the description for this stream, but I'll update it for the permanent video, which will live in a playlist. Yeah, that's fine. Okay. All right. Sorry for the meander. I'm trying to get to coding as quickly as we can get there. I'm just running through all this, prepping for the DSI start date. I think I mostly spoke to this. I think I just spoke to this, actually. Once you pass your technical interview, reach out to us. You know, we'll give you access to a pre-course, and that pre-course should be completed before day one of the DSI. Some smaller recommendations here: create a system for taking and storing notes. That, when I went through the DSI a number of years ago, that saved me. I think it's hard to downplay how important it is to be able to access your own information and access it quickly, even if it's a single document that has everything on it that you can just, you know, do a Command F or Control F and search through and find a concept immediately. And then as you go and you reorganize that document, what you're going to find is that you just know the information better. You know how to get to it quickly. Think of it as an extension of your brain. You're not going to be able to memorize everything, which you might already be savvy to. Okay. So go ahead and I think we're on our way. How to get help with prep. So there's a few things here to consider. One of the best ways to get help with prep is if you're stuck on something, ask in the DS Basic Prep channel. We highly encourage that. You're probably already seeing that. If you're on this stream, you're likely already in prep. So either Basic Prep or Premium Prep or both, and you're already seeing everyone asking questions. If you see a typo or bad grammar, let us know. Reach out to me or Lance Bardo or Devin DeJohn, Remy Arata, or Clark Walker. Yeah, we might just make a bug fixes channel where you can post things like that when you find them. It might be an easier way to go. But for now, just reach out to me if you find some discrepancy, and I'll make a ticket for us to fix them. All right, is that it? That might be it, and we might be close to coding. Oh, Slack and Intercom. Yeah, ask questions on Slack. There's also potentially an Intercom bubble that you're seeing in the bottom right of your screen. But we really, really prefer Slack. So if something comes up, right, you see down here, this is this intercom bubble, and you can engage with us there, but it's going to have a lot of latency. We only check this every couple days in general. So if you want immediate feedback, even on the weekends a lot of the time, I end up taking days off during the week and working on the weekends a lot of the time so I can engage with more students. Reach out on Slack. That's my short statement. Hopefully that that's encouraging to some of you to just do that. Okay. There's a blurb here on Replit. I already talked about that. It's just saying, again, experiment with code. There's a statement here on pair coding. If you use Replit and you want to collaborate with somebody on, somebody who's in prep with you, reach out to them, or just put a message, say, hey, does somebody want to pair code with me? And I think you're going to get some bites on that. And what you'll find is if you're coding in front of people, which you will do a lot in your life, if you're getting into coding, you're going to do that. People are going to see your code. And often you will be working on production material with somebody else, either sitting next to them or working remotely and looking at the same document. It's one of the best ways to learn. You have somebody coding and you have somebody as reference and as guide. And it seems unlikely that having two people working on the same project code project would lead to better and faster production code. But there's a lot of studies on this, and it really does. And it's gratifying. It's also a social environment. You'll find that in coding, your expertise allows you a lot of freedom. And part of that freedom is the freedom to be social while you're doing something very technical. And if you're from other technical fields, you might not have that experience as much. So, just throwing that out there, feel free to post in the prep channels, hey, does somebody want to pair code with me and work on materials with somebody? Okay, we're into Welcome to Python. I'm just going to check Slack really quick and see if anybody has a question. Cool. Not yet. I don't see a question yet. So let's just continue forward. Welcome to Python. That's about it. And I'm just going to reiterate this point here. You're not required to complete the DSI prep materials in order to register for the technical interview. As soon as you pass the coding challenge that you get to through the admissions portal for the DSI, as soon as you pass that, you can register for the technical interview. Definitely do some self-assessment and make sure that you are ready for the technical interview, like I said. But we just have a couple simple functions there for you to write to make sure that we don't get people into the technical interview who don't know how to write anything, which is a drain on our time, and honestly, it's a drain on your time to allocate that and then not be able to write a Python function at that point. But that said, you don't need to get to 100% completion. I'm personally a completionist. I like to know everything. I like to get everything and finish everything, collect all the badges, all that stuff. But I have to discourage that because, for reasons I said before, get the technical interview out of the way. So as soon as you're ready, like minimally ready to take it, then take it. It's going to allow us to better serve you and give you access to new materials that are going to best serve you. That said, this is also true. There's a high correlation between individuals who have high completion on Learn and those individuals passing the technical interview. So do as much as you need to do, but don't do too much more than that. Okay. We're getting there. We're going to write a little bit of code, and we're going to talk some actual Python in just a few moments. So I'm going to skip this self-placement challenge. This is for you. And this is really a diagnostic tool. So if you're seeing this, you've got this self-placement challenge. It's just going to give you problems that exist in some form throughout the section that we're looking at, or the unit that we're looking at. And we're going to cover all these kinds of concepts. I just don't want to give away the answers because these are diagnostic. So this is kind of nice because if you go through and you do these, you'll figure out what you know, and you can figure out what you can skip. And this is a new feature that we've put in here. It's not a smart feature necessarily, like it's not going to give you specific recommendations. Given the current structure of our platform, we're not able to do that quite yet. But so we just say be honest with yourself. Given the results of any one of these, you're going to see a recommendation like, oh, you can skip this section or you can skip that section. So I'm just going to scroll past this and we'll get into the actual materials. So there's multiple challenge sets, and the statement we make here is if you're able to complete all these challenges unassisted within, say, an hour, you're ready to just skip intro Python and go straight to intermediate Python. Okay. There's a question here that I'll just address really quick. Someone is asking, I have found one of the coding challenge questions, I have found one of the coding challenge questions to be very difficult to understand what they're even asking. The coding is not the problem. The vagueness of the question is what's hanging me up. Is there a forum to ask for clarity on this? Yes, that forum is the channel that you are currently in, the DS Basic Prep channel. What I recommend that you do is say, I'm having trouble with this challenge on Learn, and try to name the challenge as best you can. Give a link to the challenge. So there will be a link. You can actually just copy the URL and just say, I don't understand the language and what's being asked for here. Can somebody clarify? And we'll see that. Our team will see that. And we'll go and we'll look at it and we'll say, oh, is this language vague? From our perspectives, what can we add in here to make it more clear, right? And, there are a number of problems like this. So this is a little bit of a philosophical thing in coding in general. And I don't know if you've experienced this directly, but you can definitely experience this on Code Wars. So much of figuring out how to solve a problem is figuring out what the problem actually is. And that may sound flippant, like, oh, well, people should just give better descriptions of problems. They don't, though. And we want to, don't get me wrong. We want to give you a very clear idea of what we're asking for. Something that's not ambiguous. But what you're going to find out there in the world is you are often given an ambiguous description of a problem. And we're happy to, clarify what the problem is asking to the best of our abilities. And we take suggestions, right? If you have a way of framing what we're talking about that you think would be more understandable, recommend it to us. And we'll look at it and we'll say, oh yeah, that's better than what we're saying. And we'll update that content. We might look at it and say, well, if we do this, we're giving away the answer as well. And we might choose not to implement it. But we're mostly technologists, and a couple of us are writers, copy editors, and whatnot. But there's a very small intersection, really, between technologists and writers, and only a couple of us on our team are in that intersection. Most of us are applied math, stats, data science, software engineering experts, and not as much geared toward writing. So yeah, we can always use a little help with clarity. And if you're doing problems on Code Wars, oh my gosh, there are some problems on there that are so obtusely, like, where I'll look at an easy problem and it'll take me 5-10 minutes to figure out what they're asking. Every once in a while I'll encounter a problem like that. Yeah, so please make recommendations and ask in the basic prep for clarification. Understanding the problem is half the solution. Yeah, it's really true. It sounds Yeah, it sounds a little flippant, like, hey, if you don't know, I'm not going to tell you. It's more like, if you don't know, I'm not sure how to tell you. But I'm trying to figure out how to tell you, right? Yeah. So also ask atomic questions, and that will often help you get to reasonable answers. And look at the outcomes of the errors when you run code, because often there will be really strong clues in those errors as to what we're asking for. Okay, so about Python programming, this is the overview page, and if you've seen the overview documents, there's one on every unit, and it just gives you a blurb about what we're asking for. You know, we talk about what Python is here. You know, express yourself with code. You know, programming's at an intersection between art and engineering, and that may not be obvious at this point, but what you're going to start finding is that, oh, you have an idea and you're going to use code to explicate that idea and put it into some kind of practice. Or you're like, oh, I want to make an alarm clock that does a certain thing that's really novel. You know, maybe that doesn't exist out in the world, so you have to write it yourself. This is important. Run your code often. That's why I have these coding environments set up. I could code everything within the Learn environment, but I'm mostly going to experiment, and I may not solve all the challenges as we go because, you know, I don't want to give away all the answers all the time or something like that. But this will be a walkthrough end to end, so I will do some of the challenges. But as you're going to see, the more often you run your code, the better you're going to become at reading errors and making an incremental step, taking incremental steps to solutions. Ask for help. I think I've talked pretty extensively about that. And let's just go forward. Python is an interpreted language. What do we mean by that? Well, we compare interpreted languages to compiled languages. And somebody pointed out that a lot of people don't really know the difference. You know, they don't know what a compiled language is, so why would we need to say this? We say this more to give you a sense that in an interpreted language, you get to see the results of your code pretty immediately. You don't have an intermediary step, so if I say again, I'll just do this, hello world, and run this. I'm gonna just go ahead and run this file. I'm going to see a result pretty immediately. I don't need to make an interim file, okay? In other compiled languages like C, C++, Java, which is pre-compiled to Java bytecode, or you know, any number of languages, what you do is you write code, and then you turn it into bytecode or into an executable, and then you run that executable, which is sort of a standalone problem. And what I'm going to say here is that an interpreted language you can see pretty immediately. And along those same lines, you have a Python interpreter. If you have Anaconda installed, you have IPython. If you don't, if you've just installed the basic Python environment, you can run in your terminal, in your console, you can run a Python terminal. And here I'm just typing Python, and let me type clear. Oh, I guess we don't have clear in the Python terminal. In this space, I can write Python. Hopefully you can see that. It's a little bit small at the bottom right of my screen, so I'm just going to print, hey, everyone, sort of like a hello world. And notice it's going to give me an immediate output. So in interpreted languages, you usually will have something like this. If it's Ruby, if it's, well, what's another? If it's Perl, there are a number of different interpreted languages. You have some kind of environment like this that you can where you can immediately see the results of running something. So I'll just exit out of that, and I'll show you what I usually use if I use an interpreter is IPython. IPython, I believe, is much superior to the Python terminal. It's taking a little bit of time to get itself going. All right, okay, there it is. Okay, so same thing. You know, I can just print hello world, but look how I have code highlighting. I have this this really nice distinction between the string that I'm printing in hello world and the print statement that I'm making. You know, I can do all kinds of stuff in here. I can define a function, you know, and let's do x times 5. So I'll just define that function, and then if I run function of 5, I would expect to see 25, and notice my output here is 25. So if you have, this is just a nice space, and I also want you to notice in the IPython terminal, I can do run this Python file up here, which is delme.py. That's kind of a, I'm waiting for the code to complete. Oh, I'm hoping this new computer is going to arrive in the next couple days, because it's a little, just trying to complete some code here. It's okay. It's okay, computer. You know, when you have a computer that you just feel so attached to, that you wait and wait to to replace it, because, you know, you've done so much with it. That's this machine, and it's sort of like, I don't know, I'm trying to think of a good metaphor that doesn't involve horses or something. Oh, you know, like chickens. We have chickens, and when those chickens stop laying, you know, we could eat them, but, you know, we sort of take this approach of like, oh, you know, it's lived a good life, it's given us so many eggs, let's go ahead and, oh, there we go. Let's go ahead and let it continue living in the coop, and that's probably going to be this computer, except it's just going to be for Hulu or something. Okay. So yeah, just notice I was able to run this script up here, and it just printed hello world. So I'm going to exit out of that just because it's a little bit extra overhead, and I would rather just run in my terminal. To run in my terminal, I'll do python delme.py. Of course, you can name your file anything. It doesn't need to be called delme. I just name things that if I'm going to delete them later. Okay. So let's look at the next lesson. This is just talking about text editors. I'm just going to TLDR this and say you need a text editor to write code. You can't use you're not going to be helped by using a word processing document like Google Docs or Microsoft Word or something like that. You know, this is going to limit you to text that will work and be interpretable by the Python interpreter. So that's a long story short. We say don't use an IDE if you feel comfortable using something like PyCharm and you have a lot of experience in Python. We're not going to, you know, be hardline about that by any means. For the DSI, we use VS Code. I personally use Vim, which is an in-terminal text editor. I'm not going to use Vim for the most part for you know, these study halls, because most of you haven't seen it. But Vim is kind of, Vim or V are they're universal on Linux machines, on Unix machines, that is, along with Emacs. So they're kind of convenient for that. Like if you're editing directly on a server, then you might want to use V or Vim instead of having to code something locally and push it up to the server every time. Also, you know, you get some street cred by being good at V or Vim. So, you know, if you want to, if you want to have something to casually brag about, you can say, oh, well, you know, I just use Vim. And people will say, wow, you're cool. Okay. How to program, break down a problem into atomic components to be solved one by one. You know, there are some explicit steps here, but I'm not going to go through them. I think it's fine. This is one of the lessons. If you're very new to programming, I think this is helpful to think about things in terms of being, of writing recipes, right? But we're going to be doing that. So I'll go ahead and skip to the next lesson. Okay. There's a question here. I am part of the Linux Big Brain community, so I'm using Ubuntu 2004. Will I have any disadvantages compared to using Mac? And how familiar should I be with terminal commands, scripts, etc.? You might want to... Well, you know what? I'll check on this. I think we're still recommending Ubuntu 18.4 for the Immersive, but my suspicion is at this point, TensorFlow, PyTorch, GenSim, Spacey, I think they're all well supported on Ubuntu 2004. I think we just say Ubuntu 18.04 because we're fairly sure about that, and most servers you can spin up for ML applications are going to be using Ubuntu 18.04. So so I think 2004 is fine. 18.04 is recommended, and we know we can support that. You know, you could also use, well, you're already using Ubuntu, and the question is really about Ubuntu versus Mac OS. The advantage, I think, in using Mac is it's just easy to do installs. I mean, to be quite honest, setting up your environments is really easy. That said, it can be as easy using Ubuntu, especially if you, let's say you have a GitHub repo where you store different installation scripts, where you just store different installation scripts. I think a big advantage to using Linux over Mac OS is the disposability of your operating system. To me, that's a huge advantage. I love being able to, you know, destroy my operating system, start fresh. You know, if I hit something that's a little bit irreparable, you can do that on a Mac. It's just, you know, a Mac feels more like a little less like a factory and more like a home, you know. So I use Macs because well, I use both Linux and Mac, and I do a lot of stuff in the cloud. So you know, I guess I'm sitting in both worlds a little more than some people, but but I also, you know, use my Mac heavily for streaming and for video production and sound production and things like that. So that's a little bit more cumbersome on a Linux machine. So that doesn't look to me at all like a disadvantage for the data science immersive. And if you feel comfortable in Linux, you're going to be fine. I wouldn't even worry about it. How familiar should you be with terminal commands, scripts, etc.? You're going to get familiar, is my short answer. I believe in the pre-course there is a section. If it's not in there yet, it's going to be in there soon. And if I didn't say this before, the pre-course is what you should complete prior to day 1 of the DSI. That's after you've passed the technical interview. In pre-course, I believe we cover rudimentary bash scripting, you know. But of course, maybe this isn't an of course, but bash scripting is wildly useful. And most things that you can do, well, I think I can, I won't say this. Most things that you can do in data, you know, is just sort of traversing your data using Python. You could use bash, and some of that will be covered in the DSI, but you don't really need to know that before the DSI. You just need to be able to say, run code in the terminal, navigate the terminal, move some files around, run a Jupyter notebook, those kinds of things. Okay. Python documentation and resources. There are official docs for Python. You know, you'll find yourself referencing those here and there. They're good, but more often I think what you'll find is searching Stack Overflow or you know, looking at more elementary resources if you're fairly new to Python or new to programming will be easier than looking at the official docs. The official docs are written for programmers more than they are written for beginners. there are tutorials and there are specific function references that you'll probably want to start looking at. Yeah, that's what I have to say about that. There's also the Python enhancement proposals called PEP. There's the PEP 8 style guide. And at some point, once you are at a fair level of proficiency, I wouldn't say right now, unless you're really meticulous, like if you're really into grammar or really into doing things exactly the right way. These are community guidelines for the style of your code. And I don't follow all of PEP 8 recommendations. And that's because I have some opinions that may not specifically correspond with PEP 8. And that's okay, you know. For example, I will heavily avoid using a while loop, and I will use an arbitrarily high number of iterations on a for loop instead of using a while loop in a lot of cases, because I think that is, I think it's a more efficient and sometimes, well, yeah, it's just a thing that I do. And I'm not recommending it, but I might even do that through some of these walkthroughs, just as demo. But we're not there yet. But that's an example where I might veer away from convention. PEP 8 is community convention, and in general, it's a great idea to follow community convention because people can read what you've written in the style of the community. Okay, getting there. We're well on our way. All right, so Python basics, this unit, I want you to notice there is a video playlist, and this is all the videos. This is in all the overviews except for that first overview we looked at. There are these videos. These videos are also embedded in the lessons, and there might be a couple videos that aren't because we've trimmed some lessons out and we've added some lessons in. You know, so we need to go through at some point and fill in those gaps, but or remove videos that are, you know, not relevant anymore. But you're able to watch all of these right here, or jump out to YouTube and watch them there, or you can just skip them in this initial overview and go straight on and watch any of the videos within the lessons. The videos are a bit exploratory. I didn't write them to follow the lesson specifically. On that same token, I'm not going to read the lessons verbatim in these study halls. I'm going to write different examples. I'm going to, you know, maybe if there's an interesting example, I'll show it and change some things up, play around with it. But you know, I think everyone is capable of reading through these materials, but I want to expound on the materials in study hall and generate, you know, help you to generate questions, you know, and also feel free to reach out if you're stuck, right? So because we haven't really started a walkthrough of, you know, we haven't really started coding yet, I'm going to go ahead and go through materials for the next hour as well. And I'm going to generally ask questions in real time as they come up, or sorry, answer questions in real time as they come up, because you know, the prior idea we've had for study hall is lecture for the first hour, address individual questions for the second hour. I don't think we're far enough into this yet to do that, and that model may not actually work. You know, this is the first time we're doing a study hall like this, sort of an end-to-end walkthrough of the materials. So with that in mind, I think this could go either way. And maybe next time it will still make sense to just continue going end to end on the materials instead of, you know, dividing the time between lecture and questions. I kind of like this format, just answering questions as we come to them. Okay, so common data types. So, you know, what is a data type? Well, a data type is a form in which data exists, and there are basic data types. What we're going to refer to in this lesson is the scalar types, And those are going to be types of data that are sort of a single thing. They aren't collections of data. They are these single types of data. And there is there's a function right here called type. This is one of a couple functions to check the type of some data. So let's just scroll down this a little bit and look at what we've got here. So we've got an integer type. And maybe I'll zoom in on this just a little bit. Yeah, that'll work. So an integer is going to be, you know, any, let's say, whole number, like 1 or 978, you know, or 3657894 so this is an integer. If we wanted it to be a float, we would add a decimal point to it, right? And we could do that number, you know, 0.0568. And that would be a float. So why don't we just use the type function to verify this. So I'm going to print the type of this number 3657894, and I'll just copy this, and I'm going to put a float on this 0567. Now, if I run this, notice we're going to print both the type of this up here and the type of this. And what I'm expecting to see is something that informs me that the first one is an integer and that the second one is a float. Okay, so just go ahead and run this and find that I have an error because I have a space preceding. And I'll run this again. Notice this says class int and class float. Now, class, what is a class? I'm not going to dig too deep into that word. For right now, think of a class as being, you know, the type of object it is. Okay. More generally, a class is like it's like a blueprint for an object, and when you and an object is a type of data, right? So an object is an instantiated class, which might not make sense at this point, but let's say you have a blueprint for a house. The house is the actual thing, right? And the blueprint is the design for the house. So in programming, a class is a design for an object. And so we can say that the class is an integer, or the class is a float. And the object itself is the thing itself, right? So 3657894 is an object that has been instantiated. It is an instance of the integer class, or the int class. So this is, you know, this type function can come in handy when you want to know what something is. You can just say, what is the type of this? And that's going to be helpful. Okay. So is there anything else to say about integers and float types? Not yet, I think. Yeah, let's move on to the type bool, which is also numeric. So all of these are what I would refer to as numeric types. There are other numeric types. These are just a few of them. So a bool is only going to have one of a couple values. So those values are going to be true. And notice I get some code highlighting here. For me, this is the color blue. And that's, you know, it can either be true or false, right? So the type of true or false is going to be class bool. And if I run this, we're going to see these three different classes listed: class int, class float, and class bool. Now, there's something kind of interesting about this. You know, there is sort of an equivalence between true, which is a Boolean, and the number 1, which is an integer. Okay, and we're going to see this a little bit more when we get to conditions, but there is this equivalence between 1 and true, and or really any number and true, and 0 with false, right? And you know, this harkens to binary. You know, 1 0 1. We can also think of as on off on, or true false true, right? There are other ways to think about it, but just for simplicity's sake, we can think of Booleans as being similar to integer 0 or 1, right? And this can get you caught up. There's actually a challenge that we're going to get to, not today, I don't think, but there's a challenge where you could run into an issue because you're checking the type of an input, and that type is going to recognize a Boolean as an integer, and you have to purposefully ignore Boolean types in order to correctly process that problem. So, you know, that's just a little seed for something in the future, but we'll see it when we get to it. Let's look at these challenges. I'm probably not going to do any of these. I think they are pretty self-explanatory. All, you know, the answers to these are in the in this lesson. So in this case, we're running the type function on the number -7. You probably know what that is offhand if you've been watching. And then the type of 7 point whatever. Notice this is just 7 point, not 7.0. If you put the decimal point or the floating point here, then it's going to infer, right? Like Python is going to say, oh, well, the type of this is a float. It's going to make that inference because of a quality called duck typing, where Python will decide what the type of something is based on, you know, what you've put there, or the things that are being operated upon. Okay. In this case, we have, you know, we're asking the type between a Boolean operation, and we'll talk about this double equal sign. This is the equivalence operator, and whenever you see this, you're going to see an output that is either 0 or 1. Or is either true or false, right? So in this case, 6 minus 3.0, does that equal 3? Is that equivalent to 3? Well, let's break this down. Actually, let's do this one. I think this is a nice one to think about because there's a subtlety here, and I think it's helpful. All right, so I'll just type this as it is, 3.0, double equals 3. Now, you might have a couple thoughts about this. Well, this left side is going to be completed first, and 6 minus 3.0 is actually going to be 3.0. Okay, is 3.0 equal to 3? Is that equal to 3? And it turns out in Python that that is equal to 3. And let's just verify this. Let's run this. Oh, I'm sorry. I'm checking the type of that operation, when really there should be a true or false result of that operation that is of type bool. So let me run that one more time. Notice this says true. 6 minus 3.0 is going to be 3.0. 3.0 happens to be equal to 3. These are different types. So there is a sort of, you know, a little bit of gray area here. We can compare a float to an integer, and we can get a Boolean outcome. And it turns out that in Python considers 3.0 to be the float 3.0 to be equal to the integer 3. So, you know, that's just something to watch out for. We'll sort of dig into this a little bit more when we consider casting, because there are subtleties here, and you know, we don't need to get into those subtleties at the moment, but there are some subtleties here. Okay. And if you know, so if you think about the result of this, what is that type? Of course, it's bool. Anytime you see this equivalence operator, you're going to be dealing with a bool. Okay. So basic arithmetic operators. After this lesson, you're going to be able to use Python as a calculator. And you know, I'm going to encourage you to do that generally, right? If you have something that you would pull up a calculator to solve, if you're new to Python, use Python as your calculator. And that'll just, I don't know if you have backgrounds in learning languages, you have probably encountered learning numbers at some point in another language. And what I figured out a long time ago is that, let's say I studied Arabic a long time ago. The thing that probably helped me the most early in the language was spending the time to do math in Arabic. And that meant being able to say numbers, being able to, you know, really talk about numbers. And what that allowed me to do, well, that really extrapolated to so many other spaces in language learning. I've noticed a similar trend amongst people learning programming, right? It's you make leaps and bounds when you can think of programming first as a mathematical communication, and then you can extend from that mathematical communication to you know, greater semantics than just the math. So, you know, if you're new to Python, do math in Python. Don't jump to a calculator to solve things. If you can help it, try to write those things using Python mathematical operators. So what are the common arithmetic operators? Well, they happen to be the common operators that we know and love, and then there's a couple more. Okay, so we've got addition. So I'll just say addition, and that's going to be, you know, the plus sign. We've got subtraction. You know, none of this should be too much of a surprise, which is the minus sign. We've got multiplication, and that's the asterisk. So that's just times, right? We have division, which is just the slash. So those are pretty intuitive. And let me make sure. Oh, sorry. We've got exponentiation. I'm going to include any of them that we are including in this lesson. Exponentiation. And that's a double asterisk, which I think makes a lot of sense, right? You're timesing it. And, you know, in a lot of languages, it would be this caret operator. So if you're translating from C or Java or something else into Python, this is a really easy, you know, thing to miss. It turns out that this caret operator in Python means something else. It's exclusive OR. So it's not a stand-in for the double multiplication. You're going to want to use the double multiplication. And what else is there? Do we list anything else in this lesson? We talk about order of operations, which is important. This is going to follow basic PEMDAS, right? Where it goes parentheses, exponents, multiplication, division, addition, subtraction, right? So this follows sort of a standard flow. So let's, when we get down here, I'll just go ahead and show some PEMDAS. So let's just print some of these. Oops. Let's print 7 plus 7, and we would expect to see 14. Let's print 10 minus 3, where we would expect to see 7. Let's print 7 times 7, where we would expect to see 49. And let's print 49 divided by 7. And here's an interesting thing. We're going to expect to see something like 7, okay? But as you'll see, it's not going to be 7. It's going to be something a little bit different from 7, the integer 7, okay? So exponentiation, let's just print 7 squared, right? Where we would expect to see 49. And let's go ahead and run this. So we get 14, 7, 49, 7.0. Okay, and 49. Now, that division is giving us 7.0. That may not be the most obvious thing offhand, okay? Now, the general rule I'm going to state here is that when you divide, you're going to end up with a float, okay? When you do this division like this, you're going to end up with a float. So 49 divided by 7 is going to be 7.0. If we want this to be an integer, explicitly an integer, we would do what's called casting, which we'll see very soon. Here I'm just taking int, the function int, and I'm going to do that, and then we'll get 7 down here. But unless I do that, we're going to get a float, and that float is going to be 7.0. Hopefully that makes sense. So let's go ahead and I'm going to comment all of this out. And if you don't know how to comment out a block of things, if you're on a Mac, it's Command/. If you're on a Linux or Windows machine, it's Control/. You just select everything, Command/ or Control/. Okay, so PEMDAS. Now, let's go ahead and use exponentiation. And we'll use parentheses. So 7 raised to the 7 plus 2. What would this be offhand? 7 raised to the 7 is going to be 49 plus 2 is going to be 51. And I'll go ahead and run that just in case there's some error there. Okay, 823,545. Oh, I'm sorry. This should be 7 squared. like that's a big number. Okay, 7 squared is 49 plus 2 should be 51. And that makes sense, right? Now, if we want to raise 7 to the 2 plus 2, then we're going to put parentheses here, and these parentheses will be evaluated first. So, rule of thumb, there's going to be a number of these rules of thumb. Err on the side of using more parentheses. Sometimes it can, make your code a little bit cumbersome, hard to read or something like that. But in general, you're going to want to make sure that you use parentheses because you're more likely, if you're supposed to raise something to the 2 plus 2, you're more likely to make an error if you don't include parentheses, and those errors are hard to track down. I recently interviewed somebody, technical interview with somebody, and I was looking at their code and I was like, this is right. I don't know why it's giving him the wrong answer. And it was this. This was pretty much exactly what it was. There was some exponentiation that it was supposed to be raising to the something plus something else, and it was only raising to the something, and it didn't include the addition that should have been attached to it. So yeah, that's just to say, error on the side of using parentheses. Obviously, in this case, because of the parentheses, the addition will be performed before the exponentiation. Okay. So if I do that and run it, we're going to get 7 to the 4th power, which is 2,401, which is obviously very different from 51. Okay. So I'm going to delete all that, and let's look at the next lesson. I have a concern I may have missed a lesson here, so let me... Nope, everything's good. Okay, great. I think we moved around a couple of the lessons. I think we used to start off with comments, but let's look at these challenges. What is the resulting type of the following operation? Ah, cool. Okay. In some of these challenges, you may have a suspicion, and I encourage you to guess. And then, take these, copy them, put them into a text editor, run it, put it into Replit, run it, and look there, and make a decision from there. True or false, what is the result of this expression? Oh, what is the result of this expression, true or false? I'll leave that for you to figure out. Again, you can copy this into a, what you could do is highlight this, copy it, you know, if you don't figure it out in your head or by hand, you can just do this, and it's going to evaluate this. You know, evaluate the left side, evaluate the right side, and return true or false, whether or not it's true or false. And I'm not going to run that. I'll leave that for you. Okay, let's look at the next lesson. Yeah, and definitely feel free to ask any questions if there are any questions. I know for a lot of you, this is probably very rudimentary material, and as we go, we'll get into more and more things. So, and I'll be exploratory. You know, we might hit a lesson where I have an idea that I'll implement in code that is fairly divergent from the lesson that we're looking at. You know, and we'll try to, you know, what is it? Be oh, it's a pedagogical technique. Oh gosh, extrapolative, right? Just, you know, I study pedagogy and I'm really into it. I really like it. Extrapolation is one of the best ways to learn. You take something and you build on it, and it makes it yours. You know, invention and extrapolation are two very strong pedagogical techniques. So I highly encourage you to invent and extrapolate. Okay. Extended arithmetic operators. These ones can be a little confusing to people who have not programmed before. If you're a programmer, you use them all the time. So let's talk floor division, which is this double slash, right? Easy to remember. It's like a single slash, but it's two slashes. We've got, I'm assuming we've got modulo after this, and that is the percent sign. Oh, and we talk about casting here too. That's great. So let's talk about casting to int, and we'll talk about casting to float. And then the really interesting one, in my opinion, is casting to bool. Yeah. And is there anything else in here? Oh, we talked about the round function. That's really helpful. Yeah, so let's talk about that as well. So we'll talk about round. Is there anything else? Okay, great. All right, so let's talk about this floor division. All floor division really is division that results in an integer. And the way you make it result in an integer is you throw away the remainder. Sorry, you throw away the whatever's to the right of the decimal point. So what I'll do here is 7 floor divided by 3, and I'll print that. And for modulo, what you get here is the remainder. Okay, so in this case, we'll do again 7 modulo 3. And 3 goes into 7 2 times, because 3 times 2 is 6, right? It doesn't go in a third time. And then 7 minus 6 is 1. So our remainder is 1. So the modulo of 7 modulo 3, the result of 7 modulo 3 is 1. And we'll see that in just a second. In fact, I'll go ahead and run those now, because I think they'll be helpful when we're thinking about the next thing here. So 7 floor divided by 3, right, is 2, because 3 times 2 is 6, and you can't put 3 in another time. You throw away the decimal point, because otherwise it would be 2 and a third, or 2.3 repeating, right? And 7 modulo 3 is 1, because you know, 3 goes in there twice, and it doesn't go in a third time. 3 times 2 is 6. 7 minus 6 is 1. So it's just the remainder. Okay. So let's cast to int. Now, I'm going to demonstrate this with the operation 7 divided by 3. Okay. So first off, I'll go ahead and comment these out. First off, 7 divided by 3, like I said, is 2.3 repeating. If we want this to not be a float, there are a couple choices. We just want the 2 from this. You know, how many times does 3 go into 7 with, you know, ignore fractions? We could do a double backslash, or we could just cast it to int. And what int will do is throw away the decimal. Now, I don't want to mislead you. This int casting of 7 divided by 3 is not exactly the same as the floor division of 7 and 3. But for our purposes, it's mostly going to be the case, okay? So int of 7 divided by 3, we're going to see that actually does get us the same result in this case of 7, floor divided by 3. So that's casting to an int. It would otherwise be a float, right? 2.333 repeating is a float. So there are times where you actually want an integer value as the result of something, and you want to throw away after a certain you want to throw away anything to the right of the decimal, and integer can be helpful in that regard. There are other use cases for that. I'm not going to talk about them here, but we might talk about them when we talk about pandas much later on. So in this case, I am going to cast to a float, and I'm just going to do the int. I'm going to take 7, which is obviously an integer, right? There's no decimal point there, and I'm just going to print the float version of 7, and just notice what we get as output. We get 7.0. 7.0 is a float. That's all that is. Fairly straightforward. Now, like I said, the interesting one here is really this casting to bool. And let me just scroll down and see if there's example code that is cool here. Okay, yeah. Okay, we'll just consider the examples that they have there. Okay, great. So let's cast a bool. Let's take the number 1.0, and let's cast that to a bool. That gets us true. Let's do the number negative 1, 2, 3, or 11, 2, 3, 4. That is also true. Now let's do the float negative 47.3. That is also true. And now let's try 0. It's false. Okay. Let's try 0.0. That is also false. Now, this kind of brings up something that'll come back around. There are values that are what I'm going to call falsy, right? And there are values that are truthy. And what the easier way to think about this, the easiest way to think about this, is that falsy values are 0 or empty. And what do I mean by empty? Well, I'm going to include even though we've seen it, I'm going to include, we haven't talked about it, I'm going to include a string. And I'm going to include a string, which is defined by these quotes. I'm using single quotes, you could use double quotes. This is empty. This string is empty. And I'm going to do another example where we have a string that has some letters in it. I'm just going to say hi. So bool of hi, this is truthy because it has something. There's something there. 0 is falsy, and empty string is false. They're both falsy because they kind of just don't have anything in them. Their values in some way that we think about them are falsy. So what we should expect to see here is a print of false and then a print of true. And that is what we see. We see false and then true. Okay, so let's consider round. Let's just print round on 75.24. Let's just see what that gets us. It gets us 75. So notice, because it's less than 0.5, it drops down to 75. Also notice it gives us an integer. Now if I change this to 75.54, I think we know what we're going to see. I'll run it anyway. We get 76. We round up to the nearest whole number. We throw away, we convert it to an integer. What about 75.5, right on the line? Let's go ahead and see what that gets us. Naturally, just like in remedial math, it rounds to the nearest number. Now, what if, here's just an experiment. I don't know what this is going to get us, but I'm pretty sure I know. 75.4, 99999999999. So, I actually don't know what this is going to get. It might get a 75, it might get a 76. My hope is that in Python it gets a 75. I'm pretty sure it will. Oh, it got a 76. Now that's pretty cool actually. So my suspicion is that it would get a 75. And if you know something about kind of underlying processes in other languages, you might know why I think that. So there are so many decimal points here that it can't be effectively stored as a float. And so what we hit is a concept. In this case, it's I believe it's precision underflow in this case. So basically, what's happening is that somewhere along the line, it can only store maybe some amount of nines. And why don't we explore this? Why don't we do this many nines instead? Let's see what the maximum number of nines is that will allow us to have it round down as opposed to rounding up. So let's find out. Ha! So that time, so let's add another 9 to it. And you may think this is silly, this is nonsensical, but it's also something that's very real in languages, because at a certain point we can't store a small enough precise value, right? And that is the nature of discrete computation, right? All of this is stored under the hood in data types, 64-bit floats in this case. And maybe this is a little over your head at this point. You'll know this later on in life after the prep courses or after you go through some comp org stuff. Under the hood, this is all stored in these discrete ones and zeros, and there are a lot of little tricks to how we store that. So I'm just going to keep adding nines to this, putting nines on the end of this until we can't actually get until it rounds up. And I think we're almost there. So, maybe I'll add 2 more nines. There we go. So I'm going to take 1 9 away, and let's see what the maximum number of nines is that we can have. And I think it's that many. There it is. Yeah, and obviously you don't need to know this. This is just something that I'm showing because I think it's a neat facet of computers, right? There are these things that may seem counterintuitive, but they are explainable. And in this case, it's that we can't store a more precise float than this. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 nines is the maximum amount we can have and still have 9.4999 round down to 75 or round down to the lower number. Okay, that was a brief aside, but let's go on. I'll go ahead and delete all of this, and let's look at the challenges and see if there's anything here. Pretty straightforward, 5 modulo 3. You can figure that out pretty easily. What is the resulting type of the following operation? Well, it's a double slash, right? That's the floor division. And we talked about what that would yield. What is the result of this expression? 2 raised to the 6 modulo 3. Well, what is 6 modulo 3? That's a really good question. And I didn't talk about that. So let's talk about that just a little bit more. So modulo is going to give a remainder. And what happens when something divides something evenly? What is the remainder? Well, it's 0, right? So what is 2 raised to the 6 modulo 3? Well, 6 modulo 3 is 0. 2 raised to the 0, you may not remember this, depending on, the last time you did some math. Anything raised to the 0th power is 1. So hopefully you realize that there is one of these, either 1.0 or 1 is the answer, right? Which one is it? I'm not going to tell you. But if you think about modulo, one of these is going to make sense. So I'll just leave that for you. But I didn't explain the evenly divisible as resulting in 0. That's actually a great... well, let me just say this. How do you figure out if a number is even or odd? Well, just mash some keys. And let's not put a line break in there, but 890235 modulo 2. Now, that's going to tell us whether or not this number is even or odd. And the way it's going to tell us is whether or not it equals 0. And so if it's even, if this is an even number, then the result of this will be true, right? If it's an odd number, the result of this will be false. So if I run this, we can see that 5, well, that's an odd number, so this should give us false. And it does. Okay. It turns out modulo comes in very, very handy. There are a lot of problems that we solve with it, and it may be a little bit new to you, but it's not too complex of a concept, but you do want to wrap your head around it pretty quick. There are some problems that are primarily solvable using modulo. Okay. Assignment and incrementation. So now we're getting into sort of the raw power of languages, and that has to do with storing things in memory. So there's this idea of a variable. We might also call this a namespace. And I often use this term namespace, and all it means is there's a space and we attach a name to it. You can say variable, also variable name, all of these things. We give a name to something. Oh, there's a quick question. Let me answer that. How would you round a float value of 75.99 repeating to the 100th place 75.99? That is a good question. I'm just going to look up round, because I usually do this in a different way that we'll talk about when we get to F strings, because usually when I'm rounding something, it's for the purpose of printing it out somewhere, and I convert it to strings when I do that. So round, table pizza, no, round, function, Python. I think there's a second parameter in the function. I just don't remember what it is exactly. I'm assuming it's just round. The first thing is the number, and the second thing is the place, like let's say the second decimal place. So I'll just open this from W3 schools. So I'm assuming the answer here would be round of 75.99999, comma 2. Oh, yep, and that's totally what it is. Okay, good. My intuition is correct. Seemingly correct. We'll find out. So I'll just print round, and this is 75.99999, comma 2. And I'm assuming that's right. Oh, not clear, but there we go. Oh, well, that makes sense. So to solve yours, 75.99, because it's 75.99 repeating, anything that rounds is going to increment the 9s up. So to represent this, we actually need to use a formatter, right? And so we'll convert it to a string. So I almost always have to look this up, which is a little embarrassing. I've been programming Python forever. But what this is going to look like in my mind is Well, let's double this with something else. Let's make a variable x, and let's just meet these halfway. I'm going to introduce a concept that we'll cover later, but first I'm just going to print this. Okay, so I'm going to make this assignment, and then I'm going to print it, and then we'll represent this in a slightly different way through limiting the display of this number to just these, just to do 2 decimal places. Okay, so if I run this, of course, I'm going to print just the number because I've assigned it to a namespace, a variable. I'll try to say variable. I'm just used to saying namespace, but I think throughout our materials we say variable or variable name. When I print it, basically what we're doing is we're saying, well, here's this name. That name contains something, and it contains a pointer to a place in memory. That place in memory contains this float value. Okay, so if I want to just show 75.99 from this number, from this value of 75.99999, then I'm actually going to use an f string here, and I believe what I do is, I think it's just that. And this is a formatter right here, and I might have to look this up if I did this wrong, but we'll find out in a second. Okay, unknown format code X for the object of type float. Okay, I always have to look this up. A little embarrassing, but Python float formatting. Just look that up. And this is the thing about I'm a big fan of memorization, and there are certain things that I have neglected to memorize, and maybe I'll just memorize this for next time. This is really jumping ahead to string formatting, the string formatting lesson. And also, you know, this is a short lesson in Google is your friend. You can find out the answer to, you know, you are not the first person to ask a given question. And so, you know, many people don't say this enough, but you know, the primary thing that you are going to find yourself doing when you're programming to solve problems is using Google and traversing Stack Overflow, figuring out better ways to search. Googling is a skill. It may seem like cheating. There is no cheating here, right? Well, I'm not going to say that. There can be cheating. There can be plagiarism for sure. But when you're thinking about a procedure, yeah, no problem. I don't mind being sidetracked. This is a study hall, and you know, this is just me not knowing offhand how to do something that I definitely should know how to do offhand. I just don't do it enough. Oh, you know what? Okay. Let me just get down to here. All right. I think it's just, is it that? Oh gosh. It might actually be that. Yeah, let's find out. This is documentation that doesn't use f strings, so it might not. Oh, okay. All right. You know what? I'll just Google slightly different than this. I'll just do this, and I'll say f string. And there is another way to do this. You could use a multiplier and use that to trim off the last couple decimal places. That is a way that you could do it. There's also a way to do it with modulo, or sorry, with a specific format of floor division. I'm not going to show that because I think it'll confuse people. But okay, yeah. What I'll do here, this is most relevant to what you'll need to know. Well, what you might need to do on the technical interview. Oh, you don't actually need to do that in a technical interview, now that I think about it. But I think that it's better to know this way of doing it. So let me just find an example and repurpose that example. There we go. Ha. Okay. There we go. So I just had this in the wrong order. And yeah, okay. So it's this. It'll be the namespace colon you know, there's 0 point, and then there'll be 2 decimal places to the right. So I believe that works. Ha, 76.00. Oh, great. Interesting. Okay. All right, so let's figure this out. And I'm going to do this. And I really thought that that was going to work. I thought it was going to, it actually, in that case, it rounds it. And I did not think it did. So let's do, oh, whoops. That is not how I want to do that. So let's do 1.009. That's fine. Huh, okay. So the other way I thought of doing that is not the way to do that either. Let's Google this. I'll just say limit float to 2 decimal places in Python. I also think sidetracking is good. I think we've covered a good amount of ground for this first one. And in the, you know, if there are any other questions, I'll answer this really quick, and then we'll wrap up the assignment incrementation. You know, feel free to ask the questions now, and I can stay on a little bit longer and answer those. Okay, limiting floats to 2 decimal points. I think what we really want to do is drop decimal points past a certain value. Yeah, these are all rounding. Okay, well, I'll solve it in a way that I definitely know how to solve it. And this may seem kind of boneheaded, but I'm going to cast it to a string. And, you know, this might actually just be the way to solve it. So what this is going to do is it's going to give me the ability to index it. And I'm going to start from the 0th index. And I'm going to go through, so this is 0, 1, 2, 3, 4, and 5. It won't be inclusive on the right. So, you know, this seems a little wrong to me, but what it's going to do is it's going to break our string. It's going to turn this into a string, break it into just this slice of the string, and then cast that back to a float, not an integer. And I believe that will give us the value that we want. Yeah. So that feels a little wrong, right? Because it's not purely mathematical. But that does work, and I'll ask people on my team if there's a better way to do that. There might actually be a consistently better way. I know we haven't learned string slicing yet, but that's something we'll get to before very long. Slicing in general. Yeah. Sorry for for the sidetrack. But often what you find in programming is that you need to track down an answer. And to me, this is a usable answer. It may not be the best answer. I just can't think offhand how you would avoid the round using string formatting or that initial approach I was taking, or that other approach I was taking of using floor division with a decimal number. So, okay, cool. So let's talk. Let's just talk variables a little bit more, and we'll talk about incrementing them. So let's go ahead and turn this into 76, just to be there. So when we assign a variable, we can actually just perform a mathematical operation here. How about 76 plus 34? That's easy enough. We should expect 110. And that's what we get. So notice we can commit a mathematical operation here, assign it to a namespace, and print that. The other thing we can do is we can increment this as we go. And I'm just going to use the incrementation operator, which is going to be plus equals. Now, you're going to notice that I don't say equals when we're talking about assignment, right? This is the assignment operator. A single equal sign is an assignment operator. What I call this is gets when I read it. I say x gets 76 because we're not saying x equals 76. We're saying that x is going to point at 76, the value 76 somewhere in memory. So if I think about x as being the idea of x being like a container for a pointer, I'm saying x gets 76. It's semantically important to me. It doesn't have to be semantically important to you. I think there's a vast minority of us who say gets when we say this. Other people have other words. Some people will say the value of x is 76. But x just technically does not equal 76. X is getting the value of 76 in some way. X gets 76, and I can increment x with this plus gets, and that's what I'm usually going to call it. X plus gets 36, and what we'll see here is that this is going to be 110. Oh, I used 34 before. I misspoke. So 76, or I mistyped. X plus gets 34 will be 110, as we can see there. So cool thing about this, so we know that x is 110 at that point, right? So it's going to be 110 at that point. We can perform other operations on this. We can do minus gets, and let's minus gets 5, and we would expect this to be 105. And let's x modulo gets 2. And this might be a little confusing. What does this mean? Well, this actually just means x is going to get x modulo 2. And that's just going to be 105 modulo 2. And notice this is an odd number, so x is going to be 1 at that point, which is what we would expect. So let me run that just to verify that x at that point on line 8 is going to equal 1. Now, or is going to point at 1, the value of x is going to be 1, however you want to say that. So let's do instead, this is evenly divisible by 3, right? So x at that point will be 0. And I'm not going to raise 0. I just want to demonstrate one more thing here. Let's do 10, right? So 105 modulo 10 is going to be 5. And we can see that there. Now, x exponentiated gets, I'm never going to actually say that. X is going to get x to the something is what I would probably say here. x exponentiated gets, let's say, well, let's just say 3. So we'd expect here to see 125. Is that true? Yes. Yeah, we get 125. So this is these are incrementation. Well, this is an assignment operator on line 2, and these semantics are helpful. They are not necessarily. Let's just call these. I'm just going to just say this is an assignment operator. The equal sign is the assignment operator. The incrementation sign. Well, these other ones are incrementation signs operators. Sorry, incrementation operators. They are what you could call compound operators, right? Because it's like plus equals or something to that effect. Okay. Is there anything else in this lesson that we should think about? Oh, I didn't use times gets here, or just incrementation through multiplication. But I think you get the idea here. We could have, well, let's just do one last one. X times gets 3, and that should give us 375. Oops. Times gets 3 should give us 375, unless I'm doing bad math, but I'm not. So 375. Cool. And oh, you know what? One more. Divided gets. It's just important to see all of these and to play around with them. And you'll find that they are easy to use, and you'll want to use them. They'll actually be less cumbersome than writing out the whole statement, like x gets x divided by something. So 375, let's just divide that by 5, which is 75, I think. 75.0, right, because when we use division, we're going to convert it to a float. Is there anything else in here? Variables are references. I mean, yeah, that's, oh, yes. So let's think about this. This is something subtly important. I'm not going to say you need to know this necessarily, but there's this function, and we do talk about it, and I use it reasonably often, and I think it's a good education tool in Python because it gives you a sense that there's this place in memory, and when you make an object, it lives in memory, right? An integer lives in memory somewhere. A float lives in memory. And the namespace, like x in this case, is actually pointing to some place in memory. And it turns out that floats, ints, bools, and also strings, when you modify them, when you change them, you're not actually changing them, you're destroying them. You're removing the pointer to where they are in memory. You're annihilating that. And you are assigning them to a new value somewhere else in memory. And that may sound weird, right? Like, well, why aren't we just changing the value in the variable? It's because the variable itself does not contain the value. It contains a memory location that points to the value. And that's subtly important, and it leads to a concept of mutability. So since we're not actually changing the value, we can't actually change the value. We change where the variable, where the namespace points to, which is different because we're changing the address. And the way that we can verify this is we can see the address of x, okay? Kind of cool. We can see the address of x by using this function called id. So I'm going to run this just to show us that when all this processing of x is done, there is an ID that we can see. And then I'm going to take this and I'm going to put it across the whole thing so that we can watch the ID change. So here's the memory, here's the location in the Python virtual memory of this object, of this value 75.0. Now I'm going to take this same function that I have on line 14, and I'm going to apply it every time. So x gets 76, And let's look at the ID at that point. Let's look at the ID after we increment it by 34 and subtract 5 and do modulo 10 and exponentiate by 3 and multiply by 3 and divide by 5. So I'm not printing out all the values. I'm still just going to print that last value where it is 75.0. And what we should see is that x at line 23 will actually have the same ID as x at 26, but everything in between is going to be different because the object is being unreferenced from the namespace x. If x is a container, it contains, we're taking, let's say x is a container, it has a piece of paper that has an address written on it. We're taking that address out, throwing it away, putting in another address to another piece of, another value, another piece of data in memory. And we're doing that over and over again until we finally settle when the value stays 75. So I'll go ahead and run that. It might be a bit of a confusing concept, but let's just observe this. So 44, so notice these are different numbers. This one looks like it's the same, but look at it, it's not actually the same. This is 61008, this is 57808. Yeah, and it changes, it's changing consistently, and then finally it this is right before we print it, and notice it's the same ID, the same memory location as down here where we finally print it. Okay. Hopefully that's not too heady. It's a little bit more information than you might need to know, and we're not asking you to deeply know it. But what you might consider is ID can be a troubleshooting tool for when you're wondering, did I modify this variable somewhere? Let me just throw a print statement with ID here, and I'll throw it over here. And if those IDs are the same, well, then the value that the variable is referencing has not changed. You know, that name still represents the same value. And if the ID is the same, if the ID is different, the name represents a different value. And that can be helpful. It's just one of many troubleshooting tools. Obviously, your best troubleshooting tool is the print statement, as you can just see values as they change. Yeah, let's look at these challenges, and then we'll call it a day for study hall. We're planning on doing study hall pretty consistently Mondays and Wednesdays. We might add a third day depending on, well, just depending on our bandwidth, but also depending on how many people utilize this. A third day might be helpful for some people. And I'm going to recall where I've left off from today, and we're going to pick up in the next lesson in the next study hall. So hopefully that will, hopefully that'll work for many of you. I'm sure some of you will be jumping in here at different times. Feel free to post questions. When we're working on Python stuff, it would be better for us really if you put questions in about Python and wait on anything for stats. But don't hesitate to post stats questions in the basic prep channel, just in general, right? When study hall shifts and goes over to stats, then we'll look at stats stuff too. Okay. All right, so let's look at this. What is the value of x after the following code executes? That should be pretty easy, right? X gets 10, x gets incremented by 2. Not too mysterious there. Y gets 8, similar problem. Y gets 8. Y modulo 3, well, 3, goes into 8 2 times, and there's a remainder of 2. So then you're exponentiating 2 by 2. That should be pretty straightforward. True or false, does the ID of x change after the following code executes? Well, what do you think? Okay. So we'll pick up next time at this next lesson. I'm just gonna, on comments. I've been using comments. I've been using inline comments, but we'll talk more extensively on comments next time. So thanks for hanging out. I'll be here Mondays, Wednesdays around the same time. I'll try to put this, I'll make announcements in the channel like I did today. when we go live, and I'll put something in the basic prep materials regarding study hall, just a quick blurb, like, you know, under where to get help, and you know, just list generally when study hall will occur, and we'll attempt to keep to that schedule pretty tightly, unless we hit, you know, unless our team runs out of bandwidth, and then we'll set it aside maybe for a few days. That very well could happen around the interview crunch time, you know, leading up to the October 5th DSI. So I think that's it. Yeah, that's it. Thanks so much. Take care, y'all, and reach out if you have any questions. You know, if you have a question, first post in the DS Basic Prep. Your peers are likely to get to it before, you know, within the next few minutes, whereas someone on our team might take, you know, an hour or two to get back to you. So, yeah, enjoy your day. If you're in the premium prep class, enjoy. And if you're in premium